In this lesson, we're going to talk about networks. We're going to start off by defining a network as a group of computers that are linked together so that information can be exchanged between them. And in order to create a network, you have to have hardware, you have to have software, and something called connecting media, meaning just the cables or the lines that connect the computers that are part of a network. And all of these have to be used so that a communication channel between all the computers on the network can be forged and information and resources can be shared. There are different types of networks. One is called a LAN, or a local area network. And just as the name would imply, it's a network that's local that connects computers that are close to one another. So you might have a LAN in a particular building or a particular organization. Now, in LANs, typically the computers will share printers, they'll share storage devices, other hardware such as scanners. And so that's one of the benefits of having a network, not only just sharing information, but also being able to share these peripheral devices so that there doesn't have to be a separate one hooked to every computer. There's also a WAN, or wide area network, and this is a network that spans a large area and connects two or more of the local area networks. An example would be maybe a company would have a wide area network to communicate between its manufacturing facility, which is in one part of the city, and then it has its corporate offices in another part of the city. And so these two local area networks could then be connected into what is called a wide area network. Let's look at some terminology here. Many people have heard of the internet, and this is not a typo, but let's define the intranet. If you hear this term, I know that when I visited healthcare facilities and their health information departments, I'll hear them frequently talk about the intranet at their facility. The intranet is a network that uses a particular type of connecting software within a single organization. So think of it as the network within an organization that they refer to as the intranet, so inside of the organization. And then they have the extranet, which connects an entity to one or more external networks, or those networks that are outside of the organization. And then, of course, the term that we've all heard of, the internet, and that is basically a global network. It's a network of networks that can connect computers around the world. One part of the internet is the World Wide Web. And sometimes that's confusing, that people, will ask, instead of ask, well, what's the difference? I thought they were the same thing. No, it's the internet, and then one part of the internet is the WWW, or the World Wide Web. And the web, or the World Wide Web, consists of computers and storage devices on which people place HTML documents. I mentioned that briefly in a previous lesson. It's a language in which all documents that are on the web have to be written, in order to be viewed. And in order to view the language, or view those documents that are written in hypertext markup language, that's why you have to have a browser. And a browser is just a particular type of software. Examples of browsers: most everybody's familiar with Internet Explorer. That's from Microsoft. There's another called Mozilla Firefox. You may be using it. Sometimes it functions better in some of the online classes or in Blackboard than Internet Explorer does. And then another is called Safari. A lot of Mac users will use Safari browser. And so a browser, again, is just software that interprets hypertext markup language documents that are on the World Wide Web. Now we can classify networks in regard to their relationship with other computers on the network. And notice on the slide it says computers or nodes on the network. Any computer or device that's hooked to a network is referred to as a node. We can have peer-to-peer networks and client-server networks, and we're going to define each of these. Now, in a peer-to-peer network, in a small setting, up to around 10 computers or so, files and printers can be shared using a peer-to-peer network. Think of the definition. What is a peer? A peer is an equal. It's someone, your peers are your fellow students. Your peers are those people that you work with that are on the same, basically the same level in the organization. So a peer-to-peer network allows all these networked computers to share files and also peripheral devices such as printers. So a peer is a member of the work group with whom resources are to be shared. So it's one of the computers on the network. The controls for the network and the program software must be installed on all the linked computers, but the peripheral devices such as the printers and the scanners need to be connected to only one location. And so when we look at that term peer-to-peer and we say a peer is an equal, well, in this type of network, all of the peers or computers on the network actually have all the software installed in them. There's not a particular server, meaning a master computer that has all the software and instructions on it. Every one of them have software installed on them, but their major function of this type of network is to be able to share those peripheral devices. So this is the basic setup of a peer-to-peer network. So you'll see that they are all connected, but they are also all connected to the actual printer, and they can access it. Again, it can be a scanner, and that's the major benefit of having a peer-to-peer network, and it's usually in a small area. Another type is called a client-server network. Again, when you're determining, what are these types of networks, what are the characteristics, look at the name, client-server. So a client would be someone who is getting a service, and the server is the one providing it. And so some organizations have client-server networks, and this organizes the nodes or those computers on that network. And if it's on a client-server network, it's called a client computer, but organizes the nodes so that they're served by one or more file servers that control the major functions of the network. Now, on a client-server network, you'll see the setup where the file server is basically in the middle. It doesn't have to be exactly in the middle, but it's just an illustration to show you that each computer or node is connected to that file server. The file server is where all of the software is loaded, where the data is actually stored, and each computer on the network can also share that one networked computer, printer, or any other devices. But the main difference between the peer-to-peer and the client-server is that there's software installed on all the computers in a peer-to-peer network. With a client-server, the software is actually stored on the file server or file servers and accessed by the various computers on the network. Can also have wireless networks. Many of you are familiar with these because you have them in your homes now. They're becoming more and more common. It allows for access to a network when the user is mobile. Wireless networks are connected to a local area network through a radio transceiver called an access point, which is actually wired to a router. And so in order to have a wireless network, you have to have a router, and data is sent over these wireless connection using Wi-Fi, which is a high radio frequency. And so we have Wi-Fi basically every fast food restaurant you go in. I know here at school you can sit in any of the classrooms. We have Wi-Fi. So we have wireless networks so that the students can use their portable devices here on campus. But that's becoming more and more and more common. Now, in order to have a network, you have to have all the components of the network connected in some way. So let's look at the hardware, or what we use in order to set up a network. So you have to have that connectivity hardware that includes a network card, and this is placed into an expansion slot, which we've talked about before, within the CPU case. And in order for a computer to be able to be part of a network, it has to have that network card in it. And what this network card also does is provide on the outside of the computer a place or a port to attach the cabling. And so wherever the network card is in the computer, you'll see on the outside of the computer where that port is to plug in, whether it's a telephone line or an Ethernet cord, which is the bigger internet cord that plugs in to the computer. You also have to have a modem, and a telephone line is the most common. Now a lot of people use cable instead, but the modem and the telephone line is still the most common, even though that's changing little by little. And so these are the most common ways of connecting computers to a network. Now let's talk about a modem. Modem is just short for modulation demodulation, and it's a computer device or peripheral that converts digital output signals of the computer to analog signals that can be sent over phone lines and back to digital to be processed by the computer. And so the computer, the data's digital, it has to be converted because that won't flow over most phone lines. And then once it goes over the phone lines, then it's converted back into a digital format. And so modulation is actually digital to analog, so digital from the computer to analog that will travel over phone lines, and demodulation is right the opposite, taking in the analog signal from the phone lines and then converting it back to digital so that it can be interpreted by a computer or processed by a computer. Now modems serve many purposes. They allow people to gain remote access to other computers. They allow them to transfer files, to send and receive emails and faxes. And most of the modems now allow you to actually just send faxes from your personal computer, whether you know you can or not. You probably, if it's a relatively new computer, it has a fax modem. Also, it allows the users to access online services. And so, in order to send information over a network, especially the internet, you have to have a modem in order to do that. Now a modem can be either inside the computer, you never see it, or you can have an external modem. And as I mentioned a minute ago, a fax modem can send and receive faxes. A cable modem provides internet access using high-speed TV cable connections, and so this is more and more common. It's a lot faster than phone lines. but I know that it's not available in every area. And then you can have a digital subscriber line or DSL modem that uses the phone lines, but it also uses digital signals, so it's a lot faster than using the analog phone lines. And so for high speed, you're dealing with the cable and also the DSL. With, of course, the cable is the fastest, and then DSL, and then using a regular phone line. Okay, let's talk about bandwidth. What is bandwidth? Bandwidth it denotes speed in regard to the transfer of data. So in a network, the number of bits that can be transferred in a given second over a given medium is known as bandwidth. So how fast can we transmit this data? Digital data transfer is measured in bits per second, or BPS. An example, 54K BPS would be a transfer of 54,000 bits per second. And when you hear the term broadband, it's just very high bandwidth. So it's just faster. And so you have bandwidth, and then you have broadband. And we keep using this term media. There are a number of different media used to transmit signals, and that's just basically the wires, how everything's connected. You have twisted cable. Those are just your regular phone lines, but that's what that's called, twisted cable. So regular telephone cable. It's the most common way or medium in which to hook to a network, but it is the slowest. We have coax or coaxial cable. Now that's the cable that we use to connect our VCRs or connect our cable television, our cable service to our television. It's faster than the twisted cable or the telephone cable. And then finally we have fiber optics. Fiber optic cable actually is made of glass. So tiny, 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 tiny strands of glass, and they transmit beams of light or photons. These are also used in a lot of procedures in healthcare. If someone has a colonoscopy, they use fiber optic cable to be able, the colon is not straight, and so when doing a colonoscopy, that it has to bend, but this fiber optic cable allows the physician, when doing any type of scope where they're using fiber optics, to actually basically see around corners. It has to bend, and there'll be a camera at the end and recording what's being seen. So fiber optic cable is used in that. Fiber optics, those are the same things like on the little Christmas trees where the very tips light up. Those are fiber optics. This is by far the fastest, but is the most expensive. There's something called ISDN, or Integrated Service Digital Network. And this is the backbone of the telephone networks of today. It's digital and makes use of those fiber optic cables. But the lines that run into all the homes and businesses are still old-fashioned analog phone lines called POTS, or plain old telephone service. And so there's a combination here, is that the backbone of the telephone network is digital and using fiber optics also, but the lines that run into the house aren't. So an alternative is ISDN, which is specially installed by a telephone company, and a user pays a monthly premium, and so in order to get faster internet service. The ISDN line, instead of being analog like the regular telephone lines that run into your home, it's digital, and so that's the reason that it's faster than traditional phone lines. Now the wireless media, we're sitting there, oh, okay, you said that was cable that connects everything, but not always. If you have a wireless network, you can connect those together using wireless media, which that's when the messages are basically sent through the air, electromagnetically sent through the air, using microwaves and radio waves, and also infrared rays. Now these infrared rays have to be used at a close distance. It's just like if you're using your remote control on anything, you can't get in another part of the house around a corner and try to change the channel, because those are infrared rays, and they don't travel well through walls or around corners. So you have to be at a relatively close distance. Now, in order to send data over many hundreds of thousands of miles, which we can do with the internet, communication satellites are used. And these are called geosynchronous communications satellites. Now, look at the term. Geo means Earth. Synchronous means it flies at the same altitude all the time. And so with these geosynchronous satellites, they orbit the Earth at the equator, or in the middle, at an altitude of 22,300 miles. And they're constantly orbiting the Earth, and they travel at a speed that allows it to remain in constant position to the Earth. And so the Earth's rotating, but so is the satellite. So it's synchronous with the Earth and at that constant altitude. So that's why it's called geosynchronous communication satellite. And they have the parabolic antennas that are used, and they transmit signals to and receive signals from the satellite, from the communication satellites. And so, you see those parabolic antennas all over the place, basically, but that's what is happening, that they are getting those signals from the satellite and sending signals back to the satellite. Also, there's T1 and T3 lines, and both of these are examples that you may hear these terms of high-speed telephone lines that may be used to provide broadband internet access. Now, technically, a T1 connection is a fiber optic or copper line that's separate from the regular phone line. However, that T1 line can be used for both broadband internet access in addition to phone purposes. That's what we have here on campus and throughout the state system. We have T3 lines. Sometimes you'll hear these called T-carrier lines. So these are extremely high capacity and very high speed internet connections until someone's working on the highway or the road doing construction and cuts the lines, and then you can't access anything. Such as Blackboard or we've had that happen only twice, but in the last several years. But it really brings everything to a halt when the lines get cut, and we have to go on a backup that's very, very slow. And finally, we want to talk about topologies. These are the architectures, and all this means is how the network's set up. The first is called linear bus topology. Look at the name. Linear means in a line. And so with linear bus topology, it means all the nodes on the network are connected to one primary cable called a bus, and it creates just a line, a linear bus network. So you see the file servers here. We have the nodes and the computer. We actually have the printer, which would be considered one of the nodes, and another computer, and they're all lined up, and data flows in a straight line from one computer to the other. Now, each node has what's called a transceiver, which sends messages along the bus in either direction. And as a message passes each node, the node actually, that transceiver can check for the correct address, or say, is this the right computer to receive this message? If so, it keeps it. If not, it sends it on down the line. It's just kind of like if you were to live on a street, and rather than the mail coming to everybody's house, that the mailman or mail person would leave the mail in the first mailbox. The person would come out, look at it, whatever is his or hers is kept, and then they take the rest, or that individual takes the rest to the next mailbox on the street. And the same thing goes on, and when you get to the end of the street, everybody's mail has been delivered. It's the same thing here. The next kind is called a star topology, and if you'll look at it, it's because it's shaped like a star, or the spokes on a wheel, basically. It resembles a star shape, and each node is connected to the central system by a hub. And so you'll see the hub, which is basically the router that routes the messages out to and it will route it to the individual computers. And so it's just the way, again, the architecture of the topology is the shape of the network. So here it is shaped like a star. So that hub acts as a switching station. It reads the address and then routes it to the correct node on the network. And then the last is called a ring topology, just because it is in a ring. And you'll see in this illustration the data flow. And with this, there's a connecting cable that connects everything, but rather than in a linear bus, it's in a circle. And so it's basically a never-ending circle. And so a closed circle or ring is formed, and it goes through all of the computers, and the data flows around. And again, as it flows, then it will keep flowing until it finds the appropriate computer at the right address. Now, we talked about the hardware and then the way, or the topology or architecture of a network. Now let's look at software. In order for a network system to share data, there has to be communication software installed. And the best example of this is, for example, if you wanted to go and use AOL to allow you to connect to the internet. You used to see this a lot. You know, those free CDs that you'd see in the grocery store and everywhere. If not, you didn't get them there. Yeah, AOL would send them to you. But when you signed up for service, for internet service through AOL, you had to have some software. You couldn't just, even though you had your modem and your phone lines and your everything, you didn't have the communication software. And so that's what that is. So you have to have the software, and it just manages the transmission of all the data and the information that flows between the linked computers. Now, if you were on dial-up, it also manages the dialing function on connections and instructions on how to connect to a network, connecting to the network interface card. And so that, in a nutshell, just communication software. You have to have the hardware, you have to have the software, because the software tells the computer how to act, basically, on the network. Let's look at security and privacy briefly, because that's a big issue anytime you're on a network. You don't have to worry so much if you're just on a single computer and it's not hooked to any type of network, especially the internet. But most are now, and so you have to worry about security. They can be damaged, or their integrity can be compromised in many ways when they're hooked to a network. Now, the hardware itself can be damaged by spilling a Mountain Dew on it, by fire, by theft. It can be intentional destruction, unauthorized use. There's all types of ways that the hardware itself can be damaged on a computer, and then the software can be corrupted, either by user ignorance or error, or by sabotage. So when we're dealing with all the viruses and the worms and the Trojan horses and all of those things, that is intentional sabotage, but that's using software in order to sabotage the computers that are hooked to the network. Data can be stolen or changed or erased, and those are always big concerns. And as I said, network computers are susceptible to viruses, and that's when you're going to have them if you are connected to a network, and especially the internet. They can be brought in on a particular software program on a particular drive, but normally we get them via the internet. And all that a virus is a little program. It's a little bit of code that's written that can wreak havoc once it's set loose in a computer. So that can be a code can be written to say, when this happens, when the user does this in the computer, then cause this to happen. And so that's all it is a mini program. And so when a person loads software it's contaminated or downloads an infected file, then his or her computer becomes infected. And that's why it's so important to actually have virus protection and keep it updated, because the viruses can cause all kind of problems. It can just be annoying and slow down a computer to actually destroying information on the computer. So how do we protect the computers and the network systems? We can have something called access controls, and this actually controls who can get onto a network. These are really, I say popular. They're used a lot in healthcare, because just because you can get on the hospital's computer system doesn't mean you can go run amok in it. You're either can get in it or can't, and once you do, it's limited as to what you can access, and those are access controls. So who can access the system and how much access do they have to the system. It's very common to use passwords to limit access. Also, it could be a digital signature. It can even be as sophisticated as biometrics, meaning retinal scans, handprints, those types of things. We also protect by encryption, which is a process by which data is encoded into an indecipherable code until it is decrypted at its destination and can be read. There are things called firewalls that are both hardware and software that limit access to the intranet within an organization and the extranet. And so it's special hardware and software that will limit access. I mentioned a second ago the virus protection software, which is so important that we have it, but we keep it updated. Something else, and we'll talk about these a little bit more in another lesson, but audit control software, that doesn't keep someone out of a system, but it monitors. Anytime you hear the term audit trail, it's a listing of who logged into a system, where did they go, how long did they stay there, what did they do. And so that's an audit control. It's kind of after the fact, but it can help with determining problems basically after they happen, but to see who had access to the system. And so that's what you'll hear the term audit trail also, but audit control software. So keeping track of all the system activity. We can have physical protections, meaning, and especially at work, lock the doors, have ID cards in order to get to particular areas so that there can't be any intentional theft or sabotage of systems. and again, those biometric scanning devices to allow people in and out of certain areas. And lastly, electrical surge protection. It's something that it is so important. It's just those surge protectors, most of them, if you go purchase one, you'll see that they come with a guarantee that if there's any type of problem due to a lightning strike or some type of surge and your equipment's damaged, that the company will replace it. I remember one particular time we had brand new computers here in the lab, and it was a long time ago, and the surge protectors, when somebody delivered them, they didn't automatically plug them into surge protectors, and wouldn't you know that night there was a huge thunderstorm, and it blew out the modems on 4 different machines just immediately, and it was because the phone line was not plugged into that surge protector. And so it's a relatively inexpensive thing to do to protect your equipment. Now, some of these surge protectors also have what's called UPS, or uninterruptible power supply, so that gives you a few seconds if the power were to go out to close everything out and save what you're working on. Now let's look, and I know you're saying, finally, at the summary. We talked about networks, defined them. We talked about the types of networks, network connectivity, hardware and software. Talked about bandwidth or speed, network architecture or topology, and also network security.